Yo, what's up, everybody? Welcome back. Today we are working on our image editor, and today's task is trying to make shader-generated brushes. So this is our image editor. You boot them up, you pass in a bunch of OpenGL shaders, which is kind of strange, and a few images, right? This gives you like a bunch of images you can work with. Off rip, there's not really much you can do, but we can say, hey, I would like to create a composition of these images. And in this composition, I would like to see Cersei Lannister and a Slurpee and a Bannister, maybe. And in these things, like maybe you don't want them to be like this, but maybe you want to like cut them out a little bit. So we can be like, okay, I would like to create a path that is kind of based around Cersei Lannister, and like let's kind of cut her out a little bit. Right, boom, boom, boom. This creates like a mask, which gets applied to this object. And now in our composition, we can be like, I would like to add that mask object instead, right? This is the type of thing we can do. Now, shaders are kind of like the interesting part of this project, where we might want to say, hey, I want to like tint this image, right? So we can be like, okay, let's take this thing that we made and can we just like kind of make it look like kind of like green or something, right? This is like a thing that we can do. And what's interesting here is this is not like part of the program anymore. It isn't that like we are running a shader, but this is actually passed in. This like mixed color shader is like a file that we pass in. We said, hey, I want to create this like tint thing, and the program loads up this tint.glsl. He automatically detects what like the parameters are for this thing, shows them in the UI, and lets us edit them on the fly, which is a very, very, very powerful feature. The idea here is that we could implement most of the things that like something like GIMP would do, we kind of get for free now, as long as we can do a little bit of math as a user, which is very exciting. Today, I want to do some sort of like brush generation. So right now we can like take images and stick them together. It would be nice to have some amount of control, like generate images. If this is supposed to be something that I'm going to use to like make thumbnails, right? Something that I might want to do is I want to like draw a red arrow and point at something, which is, silly, but it is what it is. Or if I want to replace my usage of like color paint, I would like to be able to draw something. And so my thought is, in the same way that like this mask is generated from this path, and this path is like editable, and like the mask will move from that thing, and then like downstream, these changes get applied. I would like to make something that's very similar to a path. I think we will call it a stroke. And the idea here is that maybe in some canvas view, we can like just start like drawing on the page, and that will generate what is like essentially some of these things, right? The difference here between like a loop or a path, is what they're called now, and a stroke, would be that a path has to be closed so that it can generate a mask. And we will say that a stroke is going to generate a distance field, we'll call it, right? So if I come in here and I like draw this thing, we kind of want to be able to like write some program that will behave in some way based off of two things. One, is like the location in the object that it's in. We're calling images objects because I don't know, we just did. But so like say that I'm like I have like some smiley face over here, right? And I kind of want to like sample from this smiley face on a brush, or maybe I want to like show the smiley face in like a bunch of spots on the brush, right? We can probably use where we are in like the space of the image to kind of like wrap into this thing. So say we're doing like a simple thing. We want to like make like a view into the smiley face in another image. We could like draw a straight line across, right? And you could maybe like try to like draw out some sort of like portal into that other image, right? And in here, basically we would use the UV coordinates that we are in this image, as well as how far we are from the center of the path, right? So if we were to just draw like one straight quick line, my thought is the shader could choose kind of how far it is willing to like look related to this thing. So we could just draw like a little lightning bolt, right? And then kind of automatically generate something that's like more like this. I don't know. That's kind of a thought. I don't really know exactly how we're going to get there right now. I'm imagining that we're going to make some sort of like distance field from this thing, right? So keep track of maybe like whether or not we're perpendicular to the tangent of the line, how far away from the line are we, and where are we in image space. Those three things seem like you could probably accomplish a lot. Then we will allow like user shaders to kind of specify how this thing will be drawn. So a simple like red brush will just kind of say, hey, so the line's like going like this. How far am I from the line? If I'm close, make it red, and if I'm not close, make it like transparent. You could do things like the spray paint canister by kind of like doing like a checkerboard shader within some sort of distance. Stuff like that. How fast we moved, yeah, that's probably interesting as well. I bet you that. Oh, or like strength of press is probably another interesting one. We can probably add attributes as we go, but I think let's start with just distance and maybe angle. I think those two things are pretty interesting. So yeah, the plan of action is we need some sort of new like environment to work in where this type of behavior will happen, will be like supported by UI. So I think we'll probably make a new object type later. I'm not sure how like UI I want this to be. Like it might be that we just want to like a button that we can press. It's like literally let me draw stuff right now, please. But for now, we'll kind of say that the draw stuff is like a new object that works on some other object. So we'll add that in. Then we'll try to like figure out how to like track strokes. Then we will try to generate some sort of SDF, and then we'll try to run some sort of shaders on them. I guess S is not true, just distance field. There's no sign here because everything is far away. I'm looking for cutting edge Swift development. Did I come to the right place? You did. Wow, crazy. Okay, so let's stop talking and start coding. Okay. So are we clean? I think we are. We did. Oh, we were kind of messing around with a lot of stuff in Happy Hour today, so I just wanted to make sure that we did commit it all. And I guess probably the place to start is we probably need a new object type. A new object type to represent strokies. Okay. So that's gonna be like here. I don't really, maybe we want to call this like drawing. The drawing is made up of many strokes. Maybe is kind of the way we want to call this. And can we just like slap that somewhere? Like here. Drawing object. And we can kind of imagine that we're going to want to store many strokes. So in here, we're going to have like probably like a nested list of points. Probably. So can we be like, we're going to have an array list, unmanaged. I hate doing nested lists in Zig. It's kind of annoying. So maybe we kind of like make a sub object that's like stroke. Right? And this is going to be like a list of points. Okay. Okay. Yes. And then here we'll have a strokes. There we go. I know that it's like, dude, you just made a double array list, but with a name for one. But it really does help my brain reason about it a little bit better, which is fair. You could even maybe say that this is like kind of like a. You could say that a stroke is editable once it's done. That might be kind of easier, but this is fine for now. This is fine. Okay. So presumably everybody's gonna yell at me because I added a thing to an enum, right? So like here, for example, we're gonna be like, surely we're gonna have to deinit this thing in some way with our allocator. And can we just write like unreachable for now? I guess we might as well just do it. We might as well just do it. Right, we might as well. Alloc is an allocator. And for each item in our strokes, we're gonna call stroke deinit with the allocator as well. And then that means this thing needs a deinit here, as well as a self as a stroke. I'm just gonna call it self points deinit alloc. All right, fine. He's mad because I actually don't know why he's mad. It seems like this should be fine. Yeah, I don't know. He's not the right color. He's supposed to turn orange if it's a member, but I guess we'll see. Oh, something about const qualifier. So this has to be like this, I think. Okay. 534. Ah, this needs to be like this, maybe? Okay. Unhandled drawing at 109. So let's figure out what's going on there. This thing is going to have some sort of like dimensions associated with him. So let's kind of say that every drawing happens on top of some other object. Okay. Right? So now our dimensions for this thing are just going to be defined by the object that we're drawing on top of. So this is going to look very similar to what we're doing for paths right now, where we just kind of like keep going into the thing below us. Okay. So now we just keep going. 25. Nope. 236. Right, so our object properties for a drawing, for now, we'll just kind of put nothing in here, but we'll probably put like brushes in here or something. I guess at the very least, we have to show, we have to be able to update our display object for this thing. So we'll kind of show all of the objects that exist, and we'll be like, can we draw on top of that thing, please? Which means that here, we probably need this to change to D, and D here, and D here as well, and maybe we'll say fix me dedupe with path. Which means that we're gonna have to have some sort of thing that we want to do when we want to update the display object. So this is gonna become from the drawing display object here. And that's just gonna look again very similar to whatever we're doing with path. But we'll call drawing here. Okay, and then here we'll say please update drawing display obj as drawing. This thing is not a drawing, and this is drawing data. And now this like as drawing needs to exist. So we have as path, as composition, as shader, as drawing. Okay. Okay. That should be some amount of stuff. Now 144 in object. He's mad because we ask for like dependencies. There are like ways for us to construct loops of dependencies. Like one object needs to be rendered by drawing many other objects, and it's possible to create a loop. So here we just need to say this allows us to like check if that thing is there, and this is just going to be like we have one display object. Simple, easy fix. At 41, who's mad now? On save, we'll just not support saving right now. This will have to get fixed, but save and load is the last thing on my list of things I care about right now. Is it composable? I think so. I think that we can probably add a drawing to a composition. That seems very likely. In the renderer, we need to be able to render this thing in some way, but I don't really know how yet, so unreachable. And we'll figure it out in the future. Well, will crash, but that's fine. And shockingly, actually, can we just do nothing? Maybe doing nothing will be a little bit nicer, because then we can at least explore the UI on this thing and stuff without just like crashing everything. So we have no way to create a drawing, which is simple. We just go, yo, I would like to create a drawing, please. And let's see how that plays out. Okay, so we're like, yo, I would like to create a drawing. And I would like to add a drawing now, please. So pub function add a drawing. What does this do? What does this do? We're going to be like, I would like to append some object, I guess. I probably returning which object we created is pretty reasonable. This thing is going to be called drawing. And his composite, he's going to be of type drawing with a drawing object. And does this thing have to have like, this thing can be default initialized. That's fine. But this thing, we might want to specify, we might want to like default set our source object to whatever is selected right now. I think that's pretty reasonable. All right, now can we create this thing? That'd be kind of sick. That'd be kind of sick. So can I be like, where's my create drawing button? What the fuck? Oh, I didn't hit save. All right, so now we can create a drawing, and when I click it, we don't draw anything, but he does seem to at least, ooh, we segfaulted. Why do we segfault there? That was when I clicked here on drawing, right? Because there's some sort of like self-reference there, but I'm surprised that that is like causing a seg fault. Object list get display object. Oh, interesting. Okay, value 3. Who has length of 4, so that seems reasonable. I'm surprised that this is causing a problem, actually. This is in, like, the dimension getting. Ah! Recursion limit. Never mind. That makes sense, because we shouldn't be able to, but yeah, we have, like, a dependency loop there. So I guess that kind of means that we should check for dependency loops there as well, but I think that that might not be a problem. We might, like, kind of dodge that wherever that's happening. I think it's likely that we happen to check for dependency loops above, so it's not a big deal. But we do need to at least like block ourselves from adding ourselves as our direct dependency. That's fucking stupid. So where's that coming from? Here, we just need to say, yo, do not let me show myself. Is it like this? Yeah. Okay, so now at the very least we can't accidentally add ourselves, but the resolution management seems to be okay. He's claiming he's a path, not a drawing, which is not great. Let's write drawing here. And then let's figure out what's next. So I guess we need to like do something on click. So that's probably in like app. We have like an input state tracking thing. And I guess here we're gonna have to do something. I don't know what. So on like mouse position set, we are going to like, I guess just forward on whatever's happening. So can we just be like, we have a display data. Do we even need this? How is like, yeah, because we switch on our self data to determine our like input state. So we do have to like at least say that we're in the display state. And then on set mouse pause, we'll be like, if we're in the display state, sorry, not display. What am I fucking talking about? It's a drawing state. I'm fucking mental. We have to check if the mouse is down. Yeah, so here will be like, mouse down is a bool, okay? Okay, that seems reasonable. So on select object, we're gonna check if we're a drawing. We're gonna say self data is equal to drawing is equal to mouse down is equal to false, right? We start with the mouse up. Then when we set the mouse down, we go drawing. We'll say d mouse down is equal to true. And on mouse up, we do the opposite. Seems reasonable. Seems reasonable. So now can we just log the mouse position if the mouse is down? Let's start there. If self mouse down, d mouse down. Let's just like print the mouse position. All right. Let's put a new line in here. And let's just see how this falls over. I don't really want to run in GDB every time because it makes me press more buttons. It's a lot of work. Okay, so let's create a drawing. Go here. So it looks like this is working. If I click in the top left corner, he does go to -1, which is good. Bottom right corner is 1, -1, sorry. -1, 1 here. Yeah, so it looks like he's like kind of correctly identifying his location in object space, which is kind of cool. Kind of cool. And so I guess we're going to have to say if the mouse is down, we're going to have some action to perform, right? So we're going to be like, I want to add draw sample. Okay. Maybe we're going to be like, yeah, I think here we're going to add a draw sample. And I think when the mouse goes down, we start a new sample, right? Because if we're going to have many strokes, then it makes sense that here we're going to have to say that, like, okay, make me a stroke, please. You know what I mean? So this thing doesn't have input actions, but we can just say, give me an input action here. Everybody else returns null. And then we say return something. So we said we were going to make like a add draw sample. And I guess we're going to be like add draw stroke is what we're going to do here. And I think there's actually no parameters here. Right? We're just like, I guess we're going to add a draw stroke at some position. Yeah. Yeah. We're going to be like, add a draw stroke at this position. And then I guess it's like add stroke sample is kind of the other thing. Not draw sample, stroke. Okay. And this is also going to be at some vec2 position. I think. It's going to look something like this. Seems like reasonable so far. Seems reasonable so far. Okay, so if we're on like... we need to like write down these things. Here. What does this thing piss... Oh, here. Okay. Okay, so... if we add a draw stroke, we have some position to put it at. And same with add stroke sample. So we're going to get this selected object if it is a drawing. We can be like D strokes. I guess maybe it makes sense for this kind of be part of him. So we can be like add stroke. And here we'll be like add sample. Okay. That seems reasonable so far. And so now we have to like go add these things to this guy. So add stroke. What's he gonna do? I guess these are certainly failable, right? Certainly. And then we have like add sample. So here, I guess the sample is going to be a position vec2, and same with here. And here will be self strokes append something, right? And here, I guess we're going to be like, this has to be public, I guess. And so does this. And then can we be like, I guess here we immediately call like add sample at the same at the position. Then here we just say last stroke. You know, something like this. Last stroke up. I don't know, something like this. I don't know. I don't know why this isn't like happy. We do need to say We need to pass an allocator here because these are unmanaged vectors. Okay, let's see where he gets mad now. He gets mad at stroke not using this thing, so like this and this, except these are self-alloc. Boom, boom. All right. Missing field points. True. I guess here will be like default initialize that shit. Okay, and then in app now we need to use this thing. So const action, try self handle input action. There we go. Cool. Now he's mad at 578. Sure, this needs to return null now. True. And 119. What's he pissed about? Do I have to write try on this? No. Oh, this has to be tryable now. I see. I see. I didn't save. Fair. And then in the lint script, when we simulate a mouse down, we need to write try everywhere we do that. All right. Good enough for now. Okay. So now we should be able to go, give me a drawing. And as I do this, we don't really have any proof that anything's happening. So let's add some renderer code to try to render our strokes. So where the fuck is this? Okay, render object with transform. Here we go. So here we're gonna do something in the drawing section, and I guess it's gonna look very similar to whatever we're doing with like path rendering. So he renders. He has some program that acts on some plane. He draws the thing underneath somewhere. He must, and then he draws his points on top. Yeah, so he has like a where does he like draw the array here? Bind vertex array, draw arrays, points, loop. So oh, he renders the child object first, then renders his line loop on top. I see. So this is gonna be a stroke program for now, I guess. We'll kind of figure out the rest as we go. But we're gonna draw the thing that we're trying to draw on top of. Then we're gonna try to draw our shit with our vertex array. I don't know what selected point is. That doesn't really matter to us. And I guess we're gonna have like for self. We might have to render many strokes. And I guess in the path program, when they add stuff to the strokes, they append it to their own vertex array as well. And then the program draws that shit. That's not what we're going to end up doing, but we can try to make a vertex array now just for ourselves. That seems reasonable. Okay. So we need some sort of stroke program. Stroke render program. And we're just going to copy paste the path render program, I think. And, you know, s path stroke. Because I think that honestly it's going to be very similar, except we're just not going to render a line loop. And we probably won't render the points. So we'll just render a line for all of these things. And there's no selected point to worry about either. Okay, cool. Num point still has to come in. That's reasonable in our vertex array. Okay. Chill. What about like the fragment shader here? Is he gonna look the same? He literally just draws white. Sure, we can just draw white for now. That's fine by me. Fine by me. Okay. So now we need to like create that thing. stroke, stroke. And then in here, we're gonna be like, hello, DTR. Oh my god. Stroke. There we go. Seems reasonable. Seems reasonable. And then we need to pass that here. Uh-huh. Uh-huh. Alright. So now I guess that means that like when we try to render this thing, we're gonna try to render some sort of vertex array. Which means that we kind of have to copy whatever we do for our path object. Oh, he's doing a lot of manual GL stuff here, which eventually we want to push all this OpenGL stuff down into the renderer code. But we're not going to do that right now because I don't want to. So every time that they add a point, they just reset the buffer data. Sure. So I guess each stroke here is going to have a vertex array associated with him of like all of the points in the stroke. This is just for now because we did talk about how we want to do like a distance field later. But I think that I want to start by just like literally like show me what's up. You know? So here when we say like function add sample, maybe we'll call it add point so there's no name collision. Okay. I don't really know what we're gonna do yet. We're gonna presumably, I guess presumably on initialization we're gonna have to do something here. I guess what do we do here? We create a vertex buffer and a vertex array, and we set the vertex array attributes. I guess we're gonna do all the same things here. And then we have set buffer data here. What do? They're like, here's a bunch of points of vec2. Can you like find them? That seems like the same thing we want to do. Which maybe means that there's some duplication here. You know, seems likely. With path and but also this isn't gonna live here for very long. This is just for debug, so it's fine. It's fine. Okay. So now we don't initially set any buffer data. And I guess this guy requires a vpause location as well. I don't really know. This must be where in the shader this thing is stored. Probably. Okay. I don't know, man. Seems reasonable. Okay, so now when we add a point, we literally just have to call set buffer data. So it's literally gonna be like the same shit as this. What is it? Self points append with allocator and point. Sure. Certainly this doesn't compile anymore because I don't know, there's lots of reasons, but last stroke add point alloc pause. Okay. Renderer zig at like 33. Why is he pissed off? Because path program doesn't d'init with an allocator. That's true. It just wasn't compiled before because there was no errors thrown afterwards. 593 here. He's pissed because vertex array is not here. Right, so here we're going to have to actually do something like this. I don't know. Something like this, which means that this guy, when he calls him, he needs to pass in the self renderer stroke program vpause location. That gets kind of forwarded on like this, which means this is GL int. Oops. everywhere. That's fine. This guy's mad at object activity 556. What's he pissed off about here? We don't return the stroke. That's true. That is true. We also need a fix me to de-init this stuff. We don't want leakies. That'd be bad. This thing is pissed off. Why? Because that seems fine to me. No field name vertex array and drawing object. All right, so we need to go for the drawing object dot strokes. We have some stroke, right? And then we have to render each stroke individually. Kind of like that. Okay. Strokes items, I guess he wants. I'm surprised that surely this doesn't run, right? Surely. Yeah, this does not look like it's drawing anything. So why is that? Can we maybe stood debug print here? Can we like, I don't know, hit a little breakpoint. So here, can we look at S points? Oopsies, PS. Okay, can we like can we log something? Debug print rendering points any. And let's just kind of see. Let's just see. What is going on? I don't want GDB. Okay. Okay. So we create a drawing. We make a struct. Okay, so it does look like we are rendering. He is attempting to render some points. Which is not optimal. That means that like add stroke, when he calls add sample, which calls add point, we bind this vertex buffer, we set our shit. I mean, we didn't really bind a buffer up here when we created our vertex array, which means that he might not have kind of correlated those pieces of data. He might not know that like the buffer is for this. Still no dice. Still no dice. Okay. So why the fuck not? Bind buffer. Vertex buffer. Create this thing, we bind it. Okay. Then every time we add a point, we update the vertex buffer. And when we add a sample, we do call add point. We don't modify the array manually. So there should be stuff in the buffer. Now, is it possible that this stuff is wrong? Or our program is just not doing what we think? So stroke program. Let's take a look here again. Stroke program. On initialization, he says here is where my stuff is. We use our program and we bind whatever vertex array we pass in. We say here is the transform that we want to use, and here is what we're trying to draw. It's possible that GL line is wrong, not the correct argument to GL arrays. I did just kind of like make that shit up, huh? Very likely. Yeah, they want line strip. I'm just like fucking high. I wish, with all my heart, something Dragon Tales, but also that there were better errors. There we go. We're step 1 complete. Step 1, we can successfully keep track of our objects and draw them. That's pretty exciting. Pretty exciting. So we have the data that we need. Now, we don't really want to keep track of it this way, though. And then what's kind of fun is if we change this, we kind of get that thing or whatever. Okay, so I think that we can say that we have some form of stroke editor. I think that that is kind of like in place, right? And now the next thing to do is to like try to generate a distance field from this thing, right? Because if we want to run a shader on this, we want the shader to run not on like the thing directly, but on some mask generated from the thing. Okay, so here's what I am thinking. I am thinking that to generate a distance field, you have some line, right? And you want to say like, how far away am I from this line? So this is going to end up in some sort of pixel grid, right? Right. And what I think we can do is we can just kind of say, draw onto a texture this line. We'll start there. And then what we can do is we can say, let me render from that texture. I will sample that texture and I will look at what is close by to me. So at each point, first we draw this, right? Then we say, okay, on a new texture, look at this texture where we drew this line and let's like initialize this whole texture with like FFFFFFF, right? Everything here is like fucking as bright as possible, right? We'll say, hey, if I am close to this thing, if one pixel adjacent to me is there, and I am FFFFF, I'm max color, max distance. I would like to update my distance to match 1 plus what I am next to. And then I think we should be able to like flip-flop between these two textures and just like keep going again and again and again and again, kind of like expanding out from the stroke. That's kind of my idea here. I don't really know if that's like slow as shit or whatever. I don't really know if it's a bad strategy, but I kind of wanted to try it and see how it plays out. Which means, I think for now, we can probably do that as this stroke render program. I think we can do this here and then kind of like readjust later. So this thing is gonna store 2 textures. Or maybe, yeah, you can just make them here, fuck it. So let's do texture 1 is like make texture of size. And this thing says he wants to be RGBA. That's fine. So let's just say that, how do we want to do this? I guess the texture needs to match the size of the image. So maybe we'll do it here. So on render, we'll make 2 textures and we'll take in the width and the height here. Okay. And then we need like frame buffers, which thankfully we can easily create by some texture. Okay, so FB1, FB2. And we're just going to say at the very end of this, we're going to restore whatever context we had. I think we can just do both of these, actually. That's fine. Okay. Then, previous diagram, my face went segfault. It really does look like somebody getting confused about a segfault. What the fuck? Okay. So I think that we are going to render into this texture with no transform, would be my guess. So can we just do like 50 renders for now? You know, let's just like, just so we can see something. We're going to bind this program. And the first thing that we are going to do is we are going to render the line into FB1. So I think we're going to have like a, oopsies. Bind this thing, right? We're going to start with FB1 bind. And then we will render, I guess first we call like clear. Dude, I swear the font changes when I reset the size like that. It just like looks funny to me now. And I think we also have to set the GL viewport to be width and height. So probably want to do it this way. Then, at the very end, I guess our stroke program is now not going to use the path fragmentator. He's going to use the stroke fragmentator. Okay. And he's going to have... We need like two programs. One that generates the initial line. One that generates the initial line, and then one that samples from the texture. So we're going to have like program... We're going to call this line program. And then SDF program, I guess, right? DF program, sorry, no S. No sign in distance field. So this is going to be like, use the path fragmentator. Okay. And then we will also make the DF program. This vpause location is going to go to line program for sure. And then the transform location is going to be like, the line program I think doesn't need it. It might. We'll figure this out as we go. Line transform location. Okay. Presumably, dude, it just looks so fucked. Okay. So let's start by just rendering to a texture in the line program and then sampling from that texture in the stroke program. I think that that's like a reasonable place to start. So in the stroke program, we're literally just like, and then I guess the stroke program is going to be using like the plane vertex shader actually, which is kind of interesting. Which means, yeah, because we're gonna like render the path to a texture, then render the texture to a quad. That's kind of what we're trying to do. You have to fix your dialog on 567. True I do. So this is interesting. Who uses? So this is gonna be the line vpause location, probably. I don't know. And then what do we do for like the plane vertex shader when we use this thing? We have like plane render program. So here we get all of this stuff that we're gonna have to use. And this is tricky. I think we don't need aspect. I think we only need vpause, vuv, and transform. And we might not even need transform if it's like 1-to-1, but we should be a little careful here. Then we could do a bunch of other stuff that I don't really give a shit about, and then we create a vertex buffer. Ugh, oh my god, this is a lot of stuff. This is a lot of stuff, man. Okay. So this stuff all seems relevant. Kind of group this stuff up like this. What is this? Is this like a int or a cint? Yeah. So vuv and transform. I actually might not need these because I think these are gonna be hard coded. I think that's pretty likely. What is it pissed about here? Oh, because I'm using equals instead of colon. It's likely that we actually only need to store the transform location because this stuff is just going to be used on like buffer binding and stuff. So what do we do in the plane render program? We like create a vertex buffer with a fixed plane, and then we set this stuff to set up like the UV coordinates and stuff. Sure, fuck it. We can make that work. I think that this is fine. If we just copy paste this for now, and then at the end we just store the location of the transform. Oh my god, I'm not very clear on any of this. Fix me heavy dupe with plane program. Okay, let's just kind of see what happens there. So I would like to bind the frame buffer 1. I would then like to draw something to it. Okay, so we'll start with like clear color. Let's just make it like red, right? Then I would like to use the other program. So we'll start with the line program. We actually don't even need this program right now, but we'll bind anyways. We want to bind to texture 1, clear the screen, bind to texture 2, use the texture render program. Okay, this is making sense so far. And then I would like to render that thing with this transform. So we are going to bind not this vertex array, but the df vertex array, which we have not stored somewhere. We will need to keep track of that. And we then want to use the transform here. That's fine. And we also have to bind some texture. It's like GL active texture 0. We probably want to do something like this. I don't know yet, but we'll kind of. So we say, give me GL texture 0 and bind me the texture that I just made. Texture 1. Okay. That seems reasonable. And then can we just like draw arrays? With a GL triangle strip. Because we're trying to render a quad here. So that seems pretty reasonable. So hopefully this will show us a red thing in whatever position our thing is supposed to be at. We don't want any bound buffer here. Can we just call this instead? Yeah, that seems maybe right. It's very unlikely that I got this right, but we need to start somewhere. So we need to write down the df vertex array, which is going to be very similar to whatever's in the plane render program. Okay, which is this like GL uint thing. Okay, and then we write this down here. And then we probably need to make like free vertex array and vertex buffer and stuff. I don't know. I'm sure we're not tracking any of this right. Fix me. Missing a lot. But we'll come back for it. 600. Line program is like this. This goes on here now. Okay. But program is not how you spell program. And return at 599. We're missing. What are we missing? Textures? Fuck that shit. We don't need that to be here anymore. Delete program. Yeah, fine. This is like. We'll clean this up later. Okay. 841 in app. He's mad because this needs a line vpos location now, not just vpos location. Renderer at 175 or whatever. He needs like the width and height of this thing. So we need to keep like the dims of our thing. Dim 0, dims 1. And then these probably have to be int cast, probably. So I think they're too wide. Okay. GL viewport mad because it's 629. He needs this to be 0, 0 first. Start at the bottom left, go to the top right. 639 is pissed because this should be DF transform location. True. GL has no member name GL texturer 0. Fuck off. Okay, let's just we can probably dream. Fuck, shader compilation failed. Which is kind of like one of the better errors you did. So no UV in the shader for this thing. That's true. We do kind of want an in UV here. Okay. So if we get a red box here, I'm gonna like lose my fucking shit. And of course we don't. Of course we don't. We get nothing. Nothing at all. I don't know. It would have been cool. You know, we can always dream. So let's, can we get away with not rendering this thing yet? And like, let's just focus on the thing we're trying to render. Which is, yeah, there's, oh, okay, that's something. I click, oh, because I have to click to get the stroke. Okay. Hold on. Okay, wait, so that means that we've kind of got something. I don't really know what. This is filling the screen, which isn't really good. We kind of want this thing to fill the parent dimensions. So here we make a texture. We bind the viewport to fill that texture. After we bind this thing, right? So if we don't do any of this stuff down here, we should see nothing happen, I think. Interesting. So it's clearing the background of like our entire thing, which kind of indicates that this like binding of textures is not doing what I want it to do, which is confusing to me. This binds a frame buffer self FBO. We create a frame buffer. Like we've used this before. Right? We have like, oh, we probably do want to reset use that temporary viewport concept too. This seems kind of likely. I'm just gonna kind of copy this because it seems reasonable instead of calling GL viewport. But I still don't understand. I would think that GL clear should do nothing. But it's not. Why is it doing anything at all? Because I would think that the clear should be applying to the bound texture. Okay, let's get rid of this like FB2 shit. Texture 2 shit. Let's just try one texture. Let's not get crazy. I wonder if we have to like bind the program first. No, that's not what we did before. Yeah, okay, why? If this thing is bound, which I believe it should be, I don't understand why the clear is applying to anything but the texture. How do I debug this? So if I don't do this, what happens? Fuck. So we don't, let's just not try to use anything. Let's just fucking clear whatever we're looking at right now. So in this case, I would think that Cersei would turn red as well. Okay, so that's kind of interesting. That's pretty interesting. So this clears the whole screen, and if I then say render to this texture instead, it does not override the Cersei Lannister stuff. It only clears the background, which is like pretty confusing. I wonder if I have to enable scissor so that I don't go out of bounds. GeoClear on frame buffer, clearing like leaking out of frame buffer or something. Like there's something weird happening here. Um. Oh, I could be because I'm changing the clear color, and it's like getting reused somewhere else. That's actually quite possible. No, this is only clear happening is at like the top level render. That's pretty interesting. Pretty interesting. GL clear, scissor. Can we do like? Okay. Wait, that's not the problem. The problem's here. That's even weirder. That's so much more confusing. What the fuck? GL clear only viewport. Um. Do I really have to do this? Does that fix it? If it does, it's kind of funny. I don't really understand, but you know, it is what it is. No, that does the op. I'm so confused. I'm kind of confused. So, how come this is leaking out? Okay, what if we just, yeah, it's quite confusing. Because I'm just confused about how, if we're binding this frame buffer and we really are drawing to this frame buffer, why is this clear leaking out anywhere else? Something about that doesn't feel right to me. You know? But maybe we like try, let's just see what happens if we try to draw. Let's see what happens if we do this stuff. I'm kind of curious now. So here we're trying to draw our red box somewhere on top, which it is kind of doing now. And what if we like scale this thing down? So we say like, I want to draw this new box, this like the red thing that we just drew, but like kind of 50% size. what does that do? So this is kind of what I was expecting to some extent. That we're like drawing some. There's something about like the coordinate spaces that aren't doing what I expect. Something about that is wrong. I wonder if it's like when we use the line program, we clear that thing, we render it to this like texture of size, width, and height. We never set the data, but I don't really think that should be a problem. We just kind of like clear it. And that worked okay for this stuff, but maybe it's not really fair because there have been some bugs in this area. So we make a texture, we bind it to a frame buffer, gen frame buffers, bind frame buffer 2D, we set the color attachment. Wonderful, right? Wonderful. What's the last argument here? Level. Okay, sure. I wonder if, like, this changes anything. I don't think it should, but maybe. Yeah, it doesn't really change shit. Okay. So then we're like, okay. We have filled up this texture with red. That's kind of the goal. We unset our frame buffer and we say, could we draw our vertex array with a scale of 0.5.5? I think we might still need to apply the input transform. There might be something there. Like, I expect the red boxes to show up kind of like in the center here, but instead it's like showing up over here, which is really strange. Like, super strange. Right? If we're trying to draw to the screen at some location, my expectation would be that, like, we're drawing, like, into this object space. I would expect, like, a 50% box that's fully red to look here, but that doesn't seem to be the case. Instead, it's, like, kind of leading out into here and shit as well. Like, what in the fuck is going on? I wonder what happens if we start, like, zooming and panning. That might give us, like, an extra clue here. Very strange. Very, very strange. Yeah, it's fucked up, dude. Super fucked. Can we just temporarily do this after? Just because I want to see, like, only what we're drawing? Yeah, something's wrong here. Where the fuck am I? Dude, I fucking hate this shit. I hate it when it goes this way. Okay, can we just do none of this scaling shit? I wonder if it's scale then the initial transform. That might make more sense. That might make more sense. Drawing. No, it's still like over there. I wonder if like are we not using like the right vertex array? So we bind a buffer with the plane vertices. We bind the vertex array. That's so confusing. Then we say this thing has some UVs and positions, which it does. Can I, like, use a different texture here? Just temporarily. Just to test, because something, like, we need to bisect here. So, can we pass in? Let's just try to render our input like a different texture. So I want you to just like fucking send in our Cersei Lannister. Oh my god. Data, file system, texture, inner. Okay. We'll do that. And this will take in texture here. And we will bind that texture here instead. I just want to see what that looks like. Because surely I'm just doing something stupid. Create a drawing. Yeah, so now it's just drawing jack shit. Why? It means that, like, can we use identity transform really quick? Is there a bug here? New transform, inner data. Like, just fill the fucking screen. Fill the fucking screen, please. Yeah, we're just getting nothing. Which means that, like, is this thing not getting set right? DF vertex array? So we... Oh, we're using the fucking wrong program when we do this stuff. Could be. Plain vertex shader. Stroke fragment shader. Go, give me this shit. Then bind this vertex array at these locations. Yeah, I don't see the problem. Nothing in here seems crazy, man. Like, just like, fuck everything line program related. Real quick, like, let's only focus on this thing. Fuck off, man. I guess this thing needs to exist. Fine. Line program doesn't exist. Yeah, okay. Let's get that shit out of the way too. I don't want to do any of this shit. I go drawing, drawing, nothing happens. Okay. Let's double check here that if we were to just use background, path program, no, program. Can we just like render the thing that we depend on just to be sure here? So what do we do here usually? We kind of do something like this. Okay, let's just try to render display object data file system texture inner. Let's start here. We gotta start somewhere. Display object dims. Display object dims. Oh, dims. My bad. If we do this, does it do what I expect? I'm expecting to see Cersei Lannister. In the drawing view. Create drawing. Click here. Still nothing. Oh, fuck. I forgot we have to fucking click to see anything. God damn it. Okay. That gives me a lot of sanity. Okay, let's try again here. Create drawing, drawing, click. Okay. We can work with this. We can work with this. I just fucking forgot. Okay. This viewport needs to only be applied to this stuff. The frame buffer. Okay. Okay. So we'll go back here, create drawing, click, click. There we go. We're filling the fucking screen. Huge for us. Huge for us. That means that we can work with a texture. So now fuck the input texture. Let's draw texture 1 now. The one that's supposed to be red. Fuck. Inner here. Draw the thing that's supposed to be red. Create drawing, drawing, click. Big win. Okay, we're fucking filling the screen with red now. Okay, now let's apply the correct transform. Okay, that's still not looking good. That's a little concerning. Why is that happening? We're using the texture that we created here. I guess we kind of want to do all of this stuff kind of in this scope. Just to really... Okay. Okay, that's still not good. Still not good. So let's just double check again. If I use the input texture instead of red box, create drawing, drawing, click, there's something interesting going on there where the clear is leaking out again. But at the very least, we know that we're drawing a quad in the right spot. Can we turn back on this? Create drawing, drawing, click. So no, that's not doing. But we also need to enable GL scissor. Oh my god. GL enable scissor. We're getting closer. GL scissor test. Oopsies, this has to go here. Create drawing, drawing, click. Still no. Fuck off, man. Okay. GL clear outside frame buffer. Like, there's something that's... There's something I don't understand. GL clear call will clear all the active draw color buffers as specified by GL draw buffers. You could change the draw buffers before executing clear call. GL clear buffer? Okay. Frame buffer? Okay. Wait. Maybe this is all I needed. Yeah, maybe that's it. So the draw buffer, draw buffer, value. What the fuck? What's the other option here? Active draw color buffers. The frame buffers table mapped to these indices. Okay. GL clear only frame buffer. Blah, blah, blah. There's so much. There's so much to ask. Maybe ChatGPT will tell me. When I execute GL clear with a bound frame buffer, the viewport is also cleared. What's up with that? Um, Boom, 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 boom. This is not helpful. Uh, Maybe we can try again. GL clear is when I have a bound frame buffer with a texture render target. GL clear seems to be clearing outside of the frame buffer as well. Is that expected? E.g. background of my window after unbinding. Background of my window, not just the texture, changes color. GL clear buffer, I think. Yeah, it did seem kind of like what I wanted. That's what I thought. This is what I thought. FBO not probably bound. Well, but it's not only doing that. So it looks like, according to this stupid idiot, then, according to him, you know, what I'm doing isn't crazy. But then, why? Why? This is such a strange behavior. And then also, it feels strange that, can we like draw something to this? Can we like render our program and like try to draw the line on it and just kind of see what happens if we do that? Like, fuck this clear. Can we like just fucking draw our line and see what happens if we do that? So how do we do this before? It was like bind the vertex array. And then just draw arrays of like this. Like, does that kind of do something sane? We did delete the line program here. So let's fix that. Yeah, what the fuck? I hate this shit, dude. This is so not the problem I'm trying to solve right now. Okay, so I go drawing, click and draw stuff. He's rendering Cersei again because this was supposed to be texture 1 inner here. Let's try again. We open this, create drawing. We draw some stuff, and now nothing is happening, which is kind of like, this is why I'm confused. It feels like the frame buffer isn't working. Kind of, a little bit. I guess we're not really checking that the frame buffer is complete. How do we do that? GL check frame buffer. It could be that we're like, we just have a broken fucking frame buffer. That would be interesting if that was the case. It could explain a lot. Status of frame buffer is this. Yeah, so 36053 does not sound right. Hand wavy, right? What are my options? I have read frame buffer. Bang. So what comes in here? We have, can we print it in hex so that we can match it with these numbers? GL debug message callback. Is that not on? I thought that I turned it on at some point, but maybe I did just forget. 8CD5, which would be very frustrating. 8CD5. He does think he's complete. He does think he's complete, so I don't really see what the problem is. I guess we should just kind of here to debug assert here that this is equal to frame buffer complete. But I do agree with you that if that thing is not on, then we should turn it on. Although every time I turn it on, it doesn't really do as much as I thought it would. Render doc doesn't seem crazy either. Okay. Message callback. It is possible that we just don't set this anywhere. Okay. So can we like kind of like try to turn this thing on and then force it to trigger? Debug callback. GL debug callback. Okay. So like what the fuck is all this stuff though? What is all this stuff? Dum bum 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 bum. Source type ID. ID, and then we have severity length message user param. Severity length message context, we'll call it here. Okay. Everything says GL enum here is GL dot. Boom, 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 boom. All right. We don't care about most of the stuff. We probably want to, at the very least, print out the message. Like this. Severity. And then, all right, let's just at least see if something happens there. So we're not seeing anything of interest there, but can we like force something bad to happen? So like if we, I don't know, if we just don't do this, that should be like a fucking broken ass frame buffer. Oh, but we just assert there. So that's good. I mean, that's good that this assertion is working. But like, can we like force some like error messages to come out somehow? Like, yeah, he's not saying jack shit. So why is this not working? GL debug callback frame buffer. Like, is it supposed to? Oh my god, go away, fuck off. In my jailbreak. Okay, sure. Give me some debug context, please. Does that change anything? Fuck. There we go. We're seeing stuff now. And if I click on this, he does get mad at frame buffer now, so that's good. So let's fix the frame buffer. Hopefully we see some fucking error logs. That'd be so cool for us. That'd be so cool. We see nothing. It's working. Ah! Oh, also, my whole computer is like slow as shit, which isn't really good. I'm kind of concerned there a little bit, not gonna lie. What the fuck is going on there? Seems fine. Alright. It does feel like there's like a leak somewhere. I'm not gonna lie. Dude, fuck this shit, man. Is it just because I'm not like freeing my textures? Probably. Probably. That would do it. Um. Okay, we'll try this again. We'll try clearing. Create drawing. Okay, so we are seeing our big ass red piece of shit again. But again, I just don't understand why this isn't going into the frame buffer and how come like my drawed when I'm trying to draw my when I'm trying to draw my white lines, that's not working either. What if we don't try to draw these in the frame buffer? Let's just try to draw our stuff directly over here. Does that do anything sane? No. So we're clearly not drawing what we think we're drawing here. Seems bad. That was working at a point in time. So we render the thing's vertex array. Oh, fuck. I probably didn't even checkpoint when it was working. Oh, that's so annoying, man. I deserve this, but I'm gonna complain anyways. I'm not setting the transform, which might be relevant here. I think we lost that somewhere along the way. So, fuck all this. Can we literally just use, like, the line program? So we set the transform here at the line transform location to this thing. Then we try to draw our fucking white line. I just want to see it come back to anything sane. Okay, here we go. We're back. We're so back. So now what happens if we do that? We try to draw that line to the texture that we're trying to render. So instead of doing this here, we do this up here. Right? We just delete whatever the fuck this says and do this. Okay. So this should draw that like white stroke to the frame buffer, and then we should render the texture as a quad back to the screen. And I'm just hoping to see like literally any indication. Oh, that's good. That's a good sign. Now, okay. That's very interesting. So this thing probably wants the line transform to just be identity. Can we go like transform identity inner data? Let's try that. Okay. So now this is tracing my finger correctly again. I do not understand. Like, if I do this clear now, I wonder if there was something about like not actually drawing was causing some sort of weird behavior. Yeah, it does kind of look that way, huh? Where the clear, if I don't call this draw arrays here, nom points, if I don't call that, it feels like, no, even now it's kind of just working the way I expect. What the fuck? Because before I was doing this. I'm gonna lose my mind. I don't feel like I changed anything. I feel like I didn't change anything, and now it's just working the way I want it to. I guess we don't question it too hard. I must not have done whatever I thought I was doing before. Fuck my life. Oh, I did add a jail clear here, which I probably don't want. Maybe that's related. Okay, we'll go back. Create a drawing, draw. Ah, okay. Never mind. Never mind. We're so back to being fucking broken and shit. Okay, so we just won't call clear, which is annoying, but it is what it is. Now, at the very least, we're drawing to a texture, and then that texture is being pushed back on top here. So this is all kind of working the way I expect. I just wish that I could clear without everything fucking up. But at the very least, the like existing alpha that's like what we happen to be putting in there has 0 alpha, so maybe it's okay to keep working here. It's annoying for sure, but okay. So the stroke color, we actually want it to be 0. We'll call this a stroke line fragment shader. We actually want to draw black here to say that anything on the line is 0 pixels away from the line. You know? You'll probably notice what went wrong in the edits. I doubt it. I think I have no idea what the fuck's going on here. We do need to use the stroke line fragment shader in the stroke program. So that goes here. Okay. Create drawing. There we go. And now let's just start trying to do like a back and forth distance field calculation. Oh, fuck, we do need to clear it though. We need to initialize the distance, man. We need to initialize the distance. Which we need to clear for. I'm gonna lose my mind. I'm gonna lose it. And then I just want to double check. Just give me 1 second. I do want to confirm that we are in fact drawing to the texture, because if we take the second draw out, nothing shows up. Yeah, so I'm gonna lose it. GL clear buffer. I guess we'll look at this again. GL clear buffer. So we need to solve this. Clear individual buffers of frame buffer. So can I see like an example of this? Draw buffer is like a particular draw buffer to clear. So is that color buffer 0 or something? If buffer is GL color, a particular draw buffer would be draw buffer I is specified by passing I as a draw buffer value. Jesus Christ. If GL depth, if it's depth, draw buffer must be 0. Okay, so can we do like clear buffer FV? No, because what is value? A pointer to the value or values to clear the buffer to. But I just want to use the clear color. The FV, IV, and UIV forms of these commands should be used to clear fixed and floating point sign integer and under. Okay. Clamping and type conversion for the fixed point color buffers are performed in the same fashion as GL clear color. I'm gonna lose it, dude. I'm gonna lose it. So here, does that mean I can only clear it with a single float value? I guess maybe this thing takes in 3 floats? 4 floats? A pointer to value or values. Yes, okay. So if we want to do clear color, (1.0, 0.0, 0.0, 1.0). Let's start there. Then we do clear buffer IV with frame buffer. The buffer to clear is going to be GL color. Right? Simple. If the buffer is GL color, a particular draw buffer is specified by passing I as a draw buffer, so 0. Right? They're saying draw buffer I is specified by passing I. And value is a 4-element vector RGB. Okay. So that's it. Right? That's it. So is our thing fucking red now? Please, God. Please, 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 God. Wait, where'd it go? Oh, I didn't finish. Okay. So now if I do this, all right. I don't know. I don't understand. I'm going to lose my shit. But it's fine. It's fine. Okay, so now we can at least clear the background. We can set a color. That's all we want, okay? We will store the distance. We will store the distance in the red channel, okay? That's all we're going to do right now. We're just going to store the channel and put red. Let's try running some iterations of flipping back and forth. So before we do anything, right, let's just whip OMG, I can draw. I'll leave the can spelt wrong there. It's kind of funnier. I can draw a texture. I can draw to a texture, then that texture to the screen. Fuck me, man. Okay, so now that we can do that, we should be able to do a loop here where we take in 2 images here now. Just kidding, we only take in 1. And let's just start by doing 1 iteration here. I think we want frame buffer 1. How do we want to do this? At the very end, we want to draw out to the screen, but before we do that, we want to kind of flip-flop between frame buffer 1 and 2, I think. So can we just do like, let's make ourselves a second frame buffer. Okay. And let's bind that thing. Okay. And then can we do 1 iteration of this? We're literally not going to do anything here. And then here we're going to try to draw texture 2 instead of texture 1. So if we don't do this stuff, we should see just kind of like trash, right? We kind of want to see like nothing of value when we click a stroke, right? So we'll start there. Create drawing, no. Fuck! Because up here, we want to swap the order of these. Wrong frame buffer is bound. It's a good thing that we specify what we expect to see, because that way we get mad. Okay, so this is what I expected. Nothing, right? Jack shit. Now, we draw the stuff that we saw it was in frame buffer 1, right? We draw that to frame buffer 2, then we draw frame buffer 2 to the screen. So we should see a little, okay, nice. He's got like some fucked up transform there, which is another good sign that we fucked something up. So we're going to use transform identity here. Which kind of, fix me probably don't need transform. But for now, we'll leave it in, because why the fuck not? Okay, now let's try to increase, let's start trying to implement an SDF here. So here he should be sampling from texture 1, which he is. And our program here should try to dial it a little bit. So I guess he's going to be like, let me sample myself, and let me sample 1 pixel over. So I guess we probably need like width here and height as integers, right? Because we need to know how far to sample over to the side, unless there's a way to like extract that. But fuck it, we'll pass it in right now. So this means that our df thing is going to have width location and height location. Okay, simple. Width and height. Okay, simple. Now here we say df width location is equal to df width location and s width height. Okay, which means that now when we try to use this thing, we should be able to use like df width location is equal to width. Okay. And height is height. It's like this. Okay. And we should do the same thing down here. Which means that now we should be able to, in the texture, sample from 1 item over. Well, first let's just make sure that everything is still working. And then it would be nice to kind of prove to ourselves that the width and the height are getting in okay. So can we kind of like maybe put in the blue channel width over 100 or something, and the G channel height over 100 or something. Okay. I guess that kind of makes sense, huh? That's not really helpful, but it's okay. So let's now think about this. We have something, and we want to look at up. Float up is going to be a vec2 of uv.x, uv.y, and the x is going to be plus 1 over this. Yes. That sounds right to me. Then, can we do if, we'll have like a vec for me is this thing. If me red is equal to greater than or equal to 1.0, we've got a fucking problem. Otherwise, we do something else. Okay, so if I'm greater than 1.0, okay, so if I'm not greater than 1.0, I just use me. But if I'm not, then I need to look at the thing above me. We'll do that. Yes. This feels like kind of like what I want to do. And this is not up, this is right, actually. So then I will say fragment is equal to right. If I am greater than or equal to 1 and right.art is not is less than 1.0. Yes. So then can we do can I also just do like yeah, let's do this. I just want to like show somehow that like something happened, you know? So I'm trying to like color it blue or something so that we have like some indication that we saw something. Why can't I see our texture, this thing? Me is a vec4. Oh, vec4, right, okay. Okay, so here I'm hoping to see some sort of like shadow thing, which we are in fact seeing, right? We can see that if we are 1 pixel to the left of the line, we are seeing it turn blue, which is like a pretty good sign that we are doing what I wanted to be doing. Which means that we're like, so let's just sample. So if I'm greater than or equal to 1.0, we're gonna sample right. We're gonna sample left. We're gonna sample up. So this is plus 1.0 over float height. And we're gonna sample down. This is not ideal in any way, shape, or form, but we're gonna take the minimum value of var. I don't know if I'm allowed to do like many element mins, so I'm just gonna do like this. And then here we're gonna go up R, down R, left R, right R. We'll say val is equal to this, and then we'll just do val plus 1.0 over 255.0. Get 1 pixel brighter, right? 1 pixel brighter. This is should be some distance away. Fuck me. Shader compilation failed at line 16. Expected identifier. He was expecting comma or semicolon somewhere. Probably here. Probably there. Please. Okay. Maybe. Can we like fucking like crank the shit out of this thing? Okay. So can we just like run this shit now? Like 40 times? Like, let's get fucking wild out here. Right? So can we just go like 4, 0 to 10, 20. Let's just get like wild out here. We do this once for 2, and then once for 1. Obviously, this copy pasting is fucking stupid. But I'm fucking stupid. You know? That's looking promising. That's looking very, very, very promising, actually. So you can see that like we're kind of getting like progressively brighter as we get farther away from the thing. So can we just run this like 100 times? Oh my god, wait, guys. That's actually kind of working. Oh god, I'm gonna lose my shit. Okay, so the final thing we do has to be applying a different shader to the final output of this like mega flip flop thing, right? So these are like intermediate. This is like an intermediate thing that we're looking at. We're looking at the SDF. Sorry, no S. The DF, the distance field for a singular stroke, which is not actually that helpful. So, okay, first we're gonna say fix me. Uh, like mega duplication with previous lines. Can we run this like more times? Like fuck it, 400 times, right? Like who's to stop us? You know, who's to stop us? Wow, sick, very cool. I guess we don't need to run it that many times. 100 is fine. Okay, so now at the very end here, we need a new program. And this new program is going to take in that thing as a texture and just do something with it. You know? Which I wonder if we can get away with like this for now. So that I don't have to think very hard. Subprogram is going to be plain render program initialized with some allocator, some vertex shader, plain vertex shader, and then can we do like mul fragment shader for now? Right? This thing didn't get an allocator as an input, really? Okay. So here's my thought. If we use the multiply fragment shader, we should be able to just multiply whatever we have with the red channel, and it should like kind of like fade out anything that's close to where we drew. Subprogram is equals subprogram. Okay. So now at the very end, instead of doing this, we're just like self subprogram render. And he's expecting the resolved uniform value. I don't know why it's yelling at me, but it is. So this is like image is equal to texture 1 inner, maybe? Texture 1 was the first thing that we rendered to, so that seems reasonable. Transform is going to be our transform. Okay. What else does he expect? Aspect. 1.0, fuck you. 1.0 aspect is a fucking lie. I guess I'll comment this out instead of deleting it. But now I believe that we should get some sort of like inverse. Oh, sorry, hold on. He's expecting uniforms, which he's expected type this thing, found that thing. Oh my god, man. Oh, I need 2 dot squigglies, of course. How could I forget? Of course it has to be like this. Yeah, so what we should see is we should see that anything that I click is kind of like passed through, which is close, except for some reason we have forgotten this. We need 2 images here, of course. Oh my god. 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 Hold on. Hold on. Hold on. Hold on. Texture is going to be a texture here. This is going to be texture inner. Really fucking confusing names. I know. It's fine. We will live. We are, again, mega prototype mode, which is why we're having so many problems. File system, texture here. Okay. Let's see it. Let's see it. So we go here, we create a drawing, we draw, we start drawing, and look at that! Look at that! We have a shader that's doing something custom with our brush stroke. I mean, it's like the world's like stupidest shader for sure. But now we can start trying to do like other brushes, right? So hear me out. Where the fuck we typed mul fragment shader? Mul fragment. We can call this like brush fragment shader. Okay. And this thing, we're gonna say he takes in the distance field. Okay. And let's make it like kind of draw red with some fall off. It's taking as long because we're at the same time. Obviously, duh, yeah, exactly. So we're gonna sample from the distance field. And we're gonna look at the red value. And this is the distance, okay? We are going to basically just say, we are going to output some sort of like red thing, depending on how far we are. So we kind of want to go like, the alpha is going to be 1 minus distance times 5 or something, right? Let's just do something. So this should kind of trend towards 0 alpha very quickly. So now we don't have to pass in this texture here anymore. We can just draw it normally like we're supposed to. Then call our thing on top. And then it should be that this like does what I expect it to do. But you know, you never know. Okay. Create drawing, drawing. Oh, tell me that isn't fucking cool, man. Tell me that's not fucking sick. So I think I want the alpha to fall off like way harder. And maybe like exponentially. Or we could do something like, we could make it like a hard thing by saying, if we can say like alpha is equal to if distance is less than, 4, 1.0, except in this language you have to do this, else 0, right? Then we just slap an alpha in here. And now we should get like a hard brush. Right? Great drawing. Fuck. Sorry. 0.1. Wrong unit. It's a hard life out here. Right? But now we have like a really hard edge on this thing, right? Which is pretty cool. Now it seems weirdly like I kind of expected that to kind of look more circular. Right? This looks like very diamond. And that's probably because the distance field generation is only sampling vertically and horizontally. And he also has to sample diagonally. Right? So here we have to do some sort of like, or do some sort of like interpolation. But I suspect that we need to do like, fix me sample in all directions and interpolate or something, right? We probably have to pick, no, it's that the fix me sample diagonally and multiply just and do min of sample plus extra dist or something, right? Or sample in a circle. Yeah, but you have to do like pixel by pixel. So you need to sample in a grid because it's we also need to account for width not equal to height. So distances change with pixel size. I guess our pixel size is always going to be, our width and height of our pixels should be the same. So never mind, that should be right. But yeah, this is gonna be pretty cool. This is gonna be pretty cool. I'm losing my fucking mind. I feel like I spent so much time just fighting fucking OpenGL today. But this is pretty sick. Pretty sick. Frame rate feels low. And, there's a lot of things to look into here. But the idea here is, at the very least, sound. Well, maybe not sound, but it works. Pretty exciting. And then we can be like, draw it on the banister, draw it on the Slurpees. Yeah, okay, pretty happy with that. Pretty happy with that. Well, I'm a fucking liar. I'm not happy, but it's okay. We got somewhere, which is exciting. Sometimes things go like that. OpenGL, fuck you, but it is what it is. I think I'm going to call it there for today. Thank you for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 4 o'clock Pacific time right now, so anywhere between 3.5 hours and now is when you should expect to see us live. If you're watching on YouTube, you are probably only watching the second half of the stream. The first half of the stream, we call it happy hour, and it's more about like cleanup and trying to like take whatever we did in this like Uber prototype mode and make it less shit. So if you want to see that stuff, that is, you have to catch us live, or check out the Patreon or YouTube member section. I think that's plug sesh. This stuff will end up on GitHub eventually. We have a GitHub link in the Twitch description. It will end up in the Svimp repo. What else? Like, subscribe, Twitch Prime, YouTube. Peace out. Twitch, let's find someone to raid.